In this video, we are going to continue with derivatives of exponential functions. You will find this on page 482 in the Namibian AS-Level Mathematics textbook, y equals mx+c to success. Let's look at another example. The equation of a curve, and this is the function, find the exact x coordinates of each of the stationary points of the curve and then determine the nature of each stationary point. Okay, so if we want to find stationary points, we must first differentiate. Now, this is just a sum and difference, so I just multiply that 2 with a half, and then it's 1. This is staying the same, and this is just that x just becomes a 1. 4 times 1 is 4. Okay, so don't forget, at this in chapter 6, we did that. At the stationary points, dy by dx is 0. So we put 0. This is just an exponential function. Factorize it. Don't forget that there's a 1. Okay, I'd rather take red. There's a 1, and there's a -5, and there's a 4. So if you factorize it, just skip it's 1, and 1, and 1, and 4. And then 4 plus, because it's in group A, 4 plus 1 is 5. And the signs are the same, and you always take the middle. So EX, and that's what I did there. Then you put this equals 0 or this equals 0. Now, don't forget, we did that in, I think in chapter 9. You can check in the book, page 396, is we go from exponential form to log form. Now, E is always representing ln. So we keep the E, actually it's the E, and we just swap that to, okay. So X is equal to ln, and then we don't, it's log E, but then we just write ln. Then it's not necessary to write the E. Then if I see ln, I know the base is E. And this also swap from exponential to logarithmic form. But now, I don't want to, because I want to stay as exact as possible. So don't work it out on the calculator and approximate it. Keep working with that ln 4 and ln x. So how do we determine the nature of the stationary points? We differentiate again. Okay, so if we take this and we differentiate again, we get 2e2x minus 5 e to the power x. Then if we substitute x in ln x, and then I just substitute, and now you can press that final step on the calculator, and then you will get 12. Okay, so it's bigger, 12 is bigger than 0, so it's a minimum point. And if you substitute 1, and you can put it, I just want to see if I see my calculator. You can just press it in on your calculator. No, I don't see it now. So you're basically just going to, you can say 2 multiply e to the power bracket 2 ln 1 close the bracket minus 5. Just press it in and you will get -3. And if it's a negative number, then it means it's a maximum point. Okay, and there I determine the nature of the stationary points. So at ln 4, it's going to be a minimum point, and at ln 1, it's going to be a maximum point. Okay, I want you to stop the video, and I want you to do number 1, and I'm going to move it a little bit up for you. Not moving up. I want you to do number 1 as well as number 4. Again, it's a practical, it's tangent, so if you cannot recall it, go back to chapter 6, go through the basics, and then just do it with the E, with the exponential function. Okay, again, you can continue the video as soon as you are finished. Let's start with number 1. It is given that the curve, so y is equal to x minus 2 e to the power x, has one stationary point. Find the exact coordinate of this point. Okay, always, I first differentiate. So if I first differentiate, I say, and remember, this is going to be the product rule. So dy by dx. Okay, now how's the product? I rewrite the first one, and I differentiate. And if I differentiate this, it's just staying ex. Plus, I rewrite the second one, and I differentiate this one. And if I simplify this, it's going to be x ex minus 2ex plus 1ex. Now don't forget that is like terms. So this is going to be x ex, and negative 2 plus 1 is just going to be negative ex, and that is my answer. But no, don't forget stationary points. So at a stationary point, what do I know? I know dy over dx will always be equal to 0. So therefore, I'm just going to put a 0, and I'm going to say ex minus, and this is the reason why we take out a common factor. Because if we take out e to the power x, we're going to get x minus 1. And then we can say e to the power x is equal to 0, or I can say x minus 1 is equal to 0. Now I want to show you this one. Let's just see if I can move this one. If I go from exponential to logarithm, then don't forget it's ln, because it's e, and I swap that too. And what will this give? It's undefined. Okay, so this is going to not give me a value, and I only have, so therefore x is equal to 1. Okay, now this is undefined. Okay. Now, if I'm going to say this, I'm going to find the exact coordinates of this point. So I must still find the y value. Now, how do I find the y value? I substitute this value of x in the original equation. So when, and I like to make it yellow again, when x is equal to 1, y is equal to, and I'm putting it in there, 1 minus 2 e1. And what is that going to give me? That's going to give me negative 1, and it's going to give me e. Okay, and I think always, it's like leaving that ln 4. So I'm just going to say, let's just move it up a little bit. I'm going to say, therefore, what is the coordinate point is, okay, and what was it? It was 1 and then just negative e. And don't leave it like that. That is exact. Okay. That is, I didn't, so this was number A. So determine the exact coordinate of this point. This was number A. But determine whether this point is a maximum or a minimum. So let's just move up a little bit. So I'm going to differentiate it again. So if I'm going to at number B, I'm going to take this and I differentiate this again. So d2 squared over dx squared. And if I differentiate this again, I'm just going to say, okay, I'm sitting again with that multiplication there. Do you see there? So I rewrite the first one and I differentiate the second one. Plus, I rewrite the second one and I differentiate, and if I differentiate x, it's just going to be 1. And don't forget, there's two terms, so I basically just did that one now, and then I differentiate this one, and it just stays this. And let's see what happens if I simplify that. So I'm going to get x ex plus ex minus ex. So basically what is going to happen, these two cancel out, and it's just going to be x e to the power of x. Okay, but now don't forget, I'm going to substitute this point in. So I'm liking again to move up a little bit. like the yellow to say when x is 1, okay, so don't forget I'm substituting in this d squared y over dx squared, okay, and I substitute 1, and don't forget I substitute it in all the values of x. So basically it's just going to give me e. But can you remember what is e? E is 2,7 if you press it on your calculator. So this is positive. So this value is bigger than 0. Are you with me? And now I'm going to say, therefore, or I think it's better just to say, therefore, minimum. Because it's positive, it's a minimum stationary point. And that's my final. Okay, it's quite long, but you have the methods from chapter, and now it's just bringing the product rule and the E, concentrating on that things. Okay, let's make space. Let's do number 4. This is actually good that you conquer the basic things in chapter 6, so that if you come to the more difficult rules, that you already know the basic things. Okay, let's start with number 4. Okay, the first one, the equation of the curve, and I always like to write it down, it's A. So what is it? It's going to be x to the power of 3, e to the power of negative x. Show that the curve has a stationary point when x is 3. Okay, so always stationary points, I first differentiate. Don't forget it's the product rule. So what do? I rewrite the first one. There's the multiply. So there's the 2. And I differentiate this one. But don't forget, if you differentiate this one, so it's just going to be negative 1 e negative x. Because the value in front is a negative, okay, of x. And then I rewrite the second one and I differentiate the first one. Okay, and this is going to give me then, it's going to give me negative x3 e minus x plus 3x squared e minus x. Now, usually I'm just trying to get this e out, okay? So if it's just going to help me in calculations. So this is going to be negative x3 plus 3x squared. Okay. So you can take out the whole common factor, but I think in this case, I think it's just going to be best to take out the e. So at stationary points, dy by dx is equal to 0. So I put a 0 there, and I have e minus x minus x3 plus 3x squared. So it's going to be e minus x equals 0, or minus x3 plus 3x squared is equal to 0. So if I was taking out, but then it will struggle to see this one, because now go from ln, so as soon as you go to, you're going to say ln 0 equals negative x, so therefore undefined. Or, okay, now in this case, I'm going to take out, I think it's just going to help you, take out x squared. Then it's going to be negative x plus 3. So if this is equal 0, so or negative x plus 3 equals 0. So therefore, x is equal to 3. And that is what they show. So therefore, x is equal to 3. That was number A. Now I go on to number B. Now, so when, okay, let's just say, find the equation of the tangent to the curve at the point. It's nothing to do with A. So I think I can clean A and then start with B. It's another point they give you, not at the stationary point. Okay, so at number 4B, so find the equation of the tangent to the curve. Oh, I could have used the formula. That would have been nice. So I think, okay, luckily I can do this. So I think, just to help me a little bit, I'm going to use this formula, which I already differentiated there. So I think I'm just going to do this, because it's not the stationary point. Otherwise, you just rewrite that one. And I say 4B. So I say when, because they tell you when x is 1. So when x is 1, I'm going to say dy by dx equals e. I can put it there, I can put it there, it doesn't matter. So negative 1, so negative 1 to the power of 3 plus 3, 1 squared, close the bracket, equals e negative 1. And this is going to be negative 1 plus 3, e negative 1. And that's going to be 2. And now just see, this is, okay, make it a fraction. Keep the 2 and take that 1. So it's going to be 2 over e. Can you see that? If you bring that one down, that exponent is going to change from a negative to a positive. Okay. So now this is just going to be, so when x is 1, I'm going to find. So this is going to be my gradient. Okay, so don't forget, this is my gradient. So find the equation of the tangent at when, so this is my gradient. But now, if I have that x is equal to 1, I think I used again the previous example. Let's just see if I was using stationary point. No, let's just find in the previous example how we are going to find that 1 over x. Okay, I have it there. So when x was equal to 1, it was 2 over x, but I first have to find that y value. So let's just move up. So that's the gradient. But if I want to see where at this x is equal to 1, what is the value of y? So substitute when x is equal to 1, find y coordinate. Let's call it like that. But always remember, if you find the y coordinate, you always substitute into the original. Now, what was there is your original. Do you see that? There is your original. So if I'm putting it in there, okay, and I'm going to even make it blue. So I'm going to, blue was that color. It's fine. Let's just make it white. So I'm going to say y is equal to, and now I'm going to say 1 to the power of 3 e negative 1. So that is going to give me 1 over, do you see, it's 1 e minus 1. And if I do exactly the same as I did there, I'm going to see it's 1 over e. So therefore, what is the coordinate? That coordinate is 1 and 1 over e. And what is that? That is the value of m. So if I come to the tangent, can you still remember tangent? Let's just move it up. I'm going to say that this is x1, this is y1, and don't forget that this is m. So what is the formula to find? So it's going to be y minus y1 equals m x minus x1. So y minus y1, and what is y1? There is y1, 1 over e is equal to m, it's 2 over e, and it's going to be x, and there is the one, minus 1. And that is going to give me an answer of, let's just simplify this. So this is going to give me y. Okay, I'm going to know. So this is going to be 2, you can say 2x over e, minus 2 over e. And don't forget to bring that one over. So plus 1 over e. Now let's just simplify this. So this is going to be, do you see that this is again like terms? Do you see this is like? Because it's over e, that there. So it's going to be the final answer of that tangent. So therefore, y equals, you can say 2 over ex, okay, there's the gradient. And if I simplify, minus 1 over e. And there y equals mx, and there is my value of c. It's just a little bit of concentration, especially with all the e's, but the method stays the same as we did in chapter 6.